Hello, and thanks for using TickBoom. In this video, I'm tackling the second of 5 questions that were common to both the standard and advanced HSC papers that were sat just yesterday. I sourced these questions from a newspaper article that was focusing on I guess the struggle that some of the standard students encountered when working through these common questions. So I thought it would be an interesting exercise to work through them all. So this is number 2 of the 5 that I'll work through. And this question reads, Mr. Ali, Miss Brown and a group of students were camping at the site located at P. Mr. Ali walked with some of the students on a bearing of 35 degrees for 7 kilometres to location A. Ms. Brown, with the rest of the students, walked on a bearing of 100 degrees for 9 kilometres to location B. And we're given a diagram here of that. So this question has 3 parts. The first part says, show that the angle APB is 65 degrees. Then we're asked to find the distance AB. And then we're asked to find the bearing of Ms. Brown's group from Mr. Ali's group and to give that to the nearest degree. So I think the first thing worth doing will be to replicate this diagram. So if I just draw our true north, and we're told we start at a point P, Mr. Ali kind of walks over to point A, and that's for 7 kilometres, and then Miss Brown walks to point B, and that's for 9 kilometres. And we're told in the question that the bearing for going to point A was 35 degrees from north, and to point B was 100 degrees from north. So part A asks us to show that the angle APB is equal to 65 degrees. So the way to show that essentially is to say the angle APB will be equal to the angle of NPB minus the angle of NPA. So you can see if we take this whole angle and subtract from it this angle, we'll get the angle APB. And we're told in the question NPB is 100 degrees and NPA is 35 degrees, and that's how you get to your 65 degrees. So we know this angle here is 65 degrees. So that's part A. Part B is to find the length of this line AB. And as with a lot of HSC style questions, we're almost given a hint by doing part A. The hint is, well, can we use what we've just worked out in part A to work out part B? And I think we can using the cosine rule. So what we can know is that cos, if I called this A, this length is A, and this length is B, and this line here is C, we know that the cos of C is equal to A squared plus B squared minus C squared on 2AB. And what we're really concerned about is C squared, so we can rearrange. We can get cos C times 2AB equals A squared plus B squared minus C squared. So therefore we'll get C squared equals A squared plus B squared minus 2AB times cos C. Therefore C, the distance we care about, will be equal to the square root of each of these things. So A squared will be 9 squared plus B squared, which will be 7 squared, minus 2 times 9 times 7 times cos 65, and that's where we see that we're using what we just worked out in part A. So now I'll just have to key that into my calculator. So we'll get 9 squared plus 7 squared minus 2 times 9 times 7 times cos 65 equals, and the square root, we get 8.76 kilometers would be the distance. And I'll just store that in my calculator because I suspect part C will probably make use of that. As I mentioned before, a lot of these HSC questions, they build up in parts. So now if we look at part C, well, I'll just write 8.76 here. We're asked to find the bearing of A to B. So if I kind of drew a north here, we're looking for this angle here. I might call that angle beta. And what we can do in terms of, we kind of really need to fill in some of these gaps. And I think knowing that the total angle here will be 360 degrees, if I can work out this angle here, I'll just call that alpha. If I can work out this angle here, which actually is easy enough to work out because it will be 180 minus 35, which is 145. So if I can work out alpha, I'll know that beta, the angle I care about, will be equal to 360 degrees minus 145 degrees minus alpha. Now, how do we find alpha? I think the sine rule will help us here because we know that sine alpha on A would be equal to sine 65 on 8.76. So we can then use that to solve for alpha. So if we can say sine alpha on 9 will be equal to sine 65 on the 8.76 that we just worked out, which kind of gives me a level of confidence that I'm on the right track. So let's solve for alpha, which would be, alpha would be equal to the inverse sine of sine 65 on 8.76 times 9, and we'll just have to key that into the calculator. So sine 65 divided by what I just saved, and then multiplied by 9, and then we want the inverse sine of that, and that's 69 degrees to 1 decimal place. And then that means we can now work out the angle we really care about, which is beta, which equals 360 minus 145 minus 69, which equals 360 minus 145 minus 69 is 146 degrees. And it only asked it to 1 decimal place, which is why I was happy to do that rounding. So yeah, that's that question. So in the end, we needed the cosine rule and the sine rule. They were the key, and also understanding what a bearing from north meant. It would have been hard to do any of that without having that first bit of understanding. Although the question really did guide us through, didn't it? Because it kind of forced us, or didn't force us, but asked us to get this angle in here first. And that kind of, knowing that you're only given the 100 and the 35, that kind of helps you or gives you the hint of what this is all about. And then it really just came down to knowing which rules to apply. In the first case, the cos rule, and then the sine rule, and then the rest was just kind of working through the trigonometry. So hopefully that all made sense and you were able to follow along with that. Next I'll work on the third of the 5 questions that were common to the 2 exams. So tick boom.